Now in this topic we will see the definite integral. To see it, let's start with the basic one. Now I know from the indefinite integral that the indefinite integral of x dx, it is x squared over 2 plus c, a variable c. Now in the definite integral, again I have the same. What's the integral of x dx? But now I have boundaries. Let's say from 1 up to 5. Now the boundaries, I have a lower boundary and the upper bound. Now I put the smallest value down and the biggest up. Now in this case, how much is going to be? I calculate again. What's the integral of x? It is x squared over 2. But now I will put my boundaries. I will not have this value c. Now how much is it? What is this notation? This notation, it means I will put the upper bound first, so it's going to be 5 squared over 2 minus, always minus, the lower bound here, 1 to the power of 2 over 2. So the answer, you see, I don't have the value c now because I put the real value, I put specific values. So how much is it going to be? 25 over 2 minus 1 over 2, which is 24 over 2, which is 12. Generally it's easy. We can see some more problems. Let's see, for example, this one. 8x to the power of 3 dx from 0 up to 4. Now let me put here a negative value from minus 2 up to 4. Now here again, first I calculate how much is the integral, the indefinite integral without c of 8x cubed. This one I have to take 8 outside of the integral and calculate basically the integral of that from minus 2 up to 4, which is 8 times, now how much is the integral of x to the power of 3? It is x to the power of 4 over 4, and the boundaries are from minus 2 up to 4. Be careful now here. 8 times, now I will open a bracket and then I will substitute, so it is 4 to the power of 4 over 4 minus 2 to the power of 4 over 4. I continue. 8 times 4 to the power of 4 over 4. Basically I can simplify this one. Let me simplify it. 4 with this one, so it's 4 to the power of 3 minus this one is going to be 16 plus 16, so it's 16 over 4. So the value is going to be 16 times 4 is 64, yes, minus 4. So it is 8 times 60, which is 480. So this is how the definite integral works. Now let's see something more interesting. Let's say that I want to calculate this integral. This is for AI AHL, and that's the, you can also have it in AAHL in IB course. Let's say I want to calculate ln x over sine x minus x squared dx from 1 up to 5. Now normally you have to calculate how much is this integral, how you can solve this so as to find the answer. Now literally I don't know how to solve it. Maybe it's solvable, maybe it's not. In pure mathematics you can see if an integral exists, so you can solve it. But if you cannot apply these theorems, literally you cannot solve it. But we have a solution here, and it's what, of course, is the calculator. So you can put the values in the calculator and solve my integral. So let me do it here. I will go to math and then go down to f integral, enter, and now you see that I have my function and I can put all the values. So I can put from 1 up to 5 ln x divided open parenthesis sine x close parenthesis minus x to the power of 2. And again, this is something that we could never do it without the help of the calculator. Dx, and I got my value, which is immediately here minus minus 0.63134, and that's the value that and that's how I can calculate whichever integral they will give me with the help of the calculator.